Hello, Rayyan.
Hello.
How are you today?
Fine, thank you.
What are you going to talk about?
Earth's history and its features.
Didn't you tell us about this before?
Yes,
So why are we doing it again?
because in the first video, my voice wasn't very clear. And in this video, I will try to make it better.
That's good. But do you remember all the information?
Yes.
Are you sure?
Yes.
That's a lot of information to remember.
Right.
Do you know that I need all these papers just to remember the questions?
That's okay.
Okay, let's begin then. I'm gonna ask you. What can you tell me about Earth's history?
The living and non-living things on Earth today weren't always around. Earth is ancient. It is very, very, very old. The Earth is older than any of the living and non-living things on it. Life on Earth has grown and changed over time. When Earth first began, there was no life on it at all. There were no lakes, no mountains, no trees, and no people. There wasn't even air for living things to breathe. Earth started out as a hot boiling ball of melted rock. Over a long period of time, Earth began to cool down and rocks began to harden into a hard outer layer known as the Earth's crust. As more time passed, rain began to fall, forming oceans. As Earth cooled down even more, air was able to settle around it. Up until this time in Earth's history, there were only non-living things on it: water, air, and land. As water and oxygen came to Earth and the planet cooled, life began to develop. The first life was in the form of bacteria. From this, animals and plants developed in the water. In time, plants and animals moved to land. After a very long time, dinosaurs began to roam. They were around for a really long time, but there still weren't any people. As planetary temperatures and weather changed, so did life on Earth. Species such as the dinosaurs and giant ferns died out, while new species such as saber-toothed tigers, woolly mammoths, and even people developed in their place.
Very good. What can you tell me about Earth's features?
Just like our face has features, like a pointy nose, rounded shiny eyes, and a wide flat forehead, the Earth also has features. And just like our features change as we grow, the Earth's features also change over time. The Earth's features are the natural shapes on the Earth's crust made up of rock or water. Man-made features can be made up of rock and water too, but they're not natural features of the Earth. Swimming pools, buildings, and football fields are all man-made features. Landforms and bodies of water are the natural features of Earth that give the surface its shape. These features temperatures can be changed over time by the movement of wind and water. This is known as weathering and erosion.
What is weathering?
Weathering is when rocks are broken down into smaller pieces by wind and water. Moving air, as well as flowing water from rain or rivers or waterfalls, can break down rock over time by constantly rubbing against it. Weathering can affect both man-made and natural features of Earth.
What about tides and currents?
They also cause weathering.
And what is erosion?
Erosion is when the broken down pieces of rocks are moved by wind and water from one place to another. Together, weathering and erosion change the shape of Earth's features and even create new ones.
Very good. What can you tell me about Earth's water features?
Water is a natural material found on Earth as salt water in oceans and seas, and as fresh water in lakes, rivers, and ponds. Oceans are Earth's largest water feature, covering most of Earth's crust with salt water. Seas are similar to oceans, but smaller in size. Lakes are large bodies of still water surrounded completely by land. Ponds are similar to lakes, only smaller. Rivers are large bodies of flowing water that move in a path over the surface of the Earth. There are many other flowing bodies of water similar to rivers, such as brooks, streams, or creeks. Waterfalls are also bodies of flowing water. They are the part of a river or a stream where the water spills suddenly downward.
Good. And what are landforms?
Landforms are the rocky features on Earth that give the surface its shape, such as mountains, plateaus, volcanoes, islands, peninsulas, plains, valleys, canyons, and caves.
What are mountains?
Mountains are enormous rocky landforms that come to a peak or point at the top. They are formed when tectonic plates collide and rise.
Good. And what are tectonic plates?
Tectonic plates are pieces of the Earth's crust. They are constantly moving and shifting very slowly. We can't see it, but they are even changing the continents. When Earth first began, there was only one big continent. Now there are 7. And a very long time from now, they will become one big continent again.
And what is under the tectonic plates?
Magma.
What is magma?
Magma is the hot melted rock below the Earth's crust.
And where can we find mountains?
Mountains exist on every continent and even beneath the ocean. Some of the highest mountains are at the bottom of the sea. Mountains are most likely to be found along the boundaries of tectonic plates.
Why?
Because this is where the tectonic plates bump into each other.
Very good. And what are plateaus?
Plateaus are landforms with high steep sides and a flat top. They can be formed by magma pushing up from beneath or from erosion wearing away mountain tops.
And what are volcanoes?
Volcanoes look like mountains with an opening near the top. They sometimes erupt or let out hot melted rock or lava from inside the earth.
So is the hot melted rock lava or magma?
Lava and magma.
How?
When the hot melted rock is under the Earth's crust, it is called magma. But when it comes out, it is called lava.
Interesting. Okay, and what are islands?
Islands are parts of the Earth's crust that rise higher than the water surrounding them. They can be formed by volcanoes or can be part of an underwater mountain range.
And what are peninsulas?
Peninsulas are areas of land surrounded by water on almost all sides.
And what are plains?
Plains are large, wide, open, flat areas of land, usually covered with grass.
And what are valleys?
Valleys are low areas of land between mountains or hills. They can be narrow or they can be large enough to build entire cities in them.
And what are canyons?
Canyons are very deep, narrow cuts or rifts in the land, often caused by rivers and other moving water.
Often caused by what?
Often caused by rivers and other moving water.
Good. And what are caves?
Caves are large open spaces or voids in the rock of Earth's crust and are often cold, dark, and wet. They are usually hollowed out over time by water or water and acid.
Acid?
Yes. When rain soaks into the Earth's surface and carbon dioxide is released by dying plants into the soil, the water and the carbon dioxide form a chemical reaction that turns the water into carbonic acid. Over time, the carbonic acid eats away at the rock and dissolves it, forming a cave passage.
Is this the only way caves can be formed?
No, some caves can be formed by lava. When a volcano erupts and lava flows across Earth's surface, the lava on the surface hardens, forming a solid roof, while the lava underground drains away, leaving an empty tube called a lava tube.
So is it a cave or a tube?
It is a cave, but they call it a lava tube.
What about the pointy-shaped rock in the caves?
Speleothems.
Yes, speleothems. What are they and how are they formed?
Speleothems are mineral deposits or rock formations that decorate most caves. They can hang down from the ceiling, sprout up from the ground, or cover the sides of the cave. The dripping water dissolves the rock into these pointy shapes, just like icicles melting.
Very good. And do you remember how fast they grow? Or how fast they are formed? Sorry.
They grow very slowly. Speleothems grow only 1 inch every 100 years.
Only 1 inch?
Yes.
In that case, how long does it take a cave to grow big enough to fit a human?
Caves can take more than 100,000 years to grow big enough to fit a human.
100 what?
100,000 years.
That's a very long time.
Right.
So the caves we have around must be ancient, right?
Right. Very ancient.
And would you like to see a cave?
Yes.
Where can we find caves?
Caves can be found underground, underwater in sea cliffs, in hillsides, or in mountains. Most caves are formed in rocks that can dissolve more easily, like limestone, marble, dolomite, and gypsum.
Nice. Very good. Very good, Rayyan. And how much did Earth change since its beginning? And how much time did it take to change?
Since its beginning, Earth has changed drastically. Most of the changes, such as those caused by weathering and erosion, usually happen slowly over an extremely long time. Canyons and caves are usually created by moving water, breaking off pieces of rock, and moving them away. The shape of mountains and plateaus usually changes over time as wind breaks away and throws tiny particles of rock against them.
Is Earth still changing?
Yes.
How do you know? It always looks the same.
It might look the same every day to us, but the Earth continues to change as it has since its beginning. Often we can't see the changes because they happen so slowly. However, there are some changes that we are able to see because they happen quickly, such as volcanoes erupting, mudslides, and earthquakes. These changes are more evidence that the Earth is still changing because we see them as they happen. They can happen suddenly and can cause significant changes in the shape of the land very quickly.
What causes these quick changes to happen?
These quick changes happen because Earth's outer layer is constantly changing and shifting, kind of like bits of cereal floating on milk. The pieces of Earth's crust move and bump into other pieces. Sometimes we can even feel the Earth moving beneath us. When the land moves and shakes, we call it an earthquake. Earthquakes happen when two pieces of crust shift and bump into each other. This can cause big changes in the way the Earth looks.
Very good. What what else causes quick changes?
Volcanoes. When a volcano erupts, hot melted rocks or lava flows up and out through its center and down its edge. When the lava cools, it forms new hard rock on the Earth's surface. That's quite an exciting change, and one we can observe.
Very good. What evidence can scientists use to learn about Earth's history?
Scientists use fossils to learn about Earth's history. Fossils are evidence or clues that tell us about living things from long ago. As animals died and debris covered them, some animal and plant shapes were perfectly preserved in stone. Leaves, insect imprints, even dinosaur bones harden into fossils. Over time, the fossils get buried underground or underwater by the constant changes happening on Earth.
How do scientists know what time period the fossil specimens which they find are from?
Fossil clues help us pinpoint specific times in Earth's history. The more layers of rock and dirt they are buried under, the older they are. Fossils that aren't as old are found closer to the surface that we walk on, buried under fewer layers of dirt and rock. Scientists dig down through the layers of Earth to find older and older fossil specimens. Different plant and animal specimens within the same layer of Earth would have lived during the same time period.
Very good. And what does fossil evidence help us understand?
Fossil evidence leads to an understanding of the development of life on Earth. When we know the time period that plants and animals lived in, we get a better picture of what the Earth looked like at those times and how much it has changed.
What else can scientists figure out by observing fossils?
Scientists can figure out a lot about ancient plants and animals from long ago by observing their fossils. They can figure out their shape and size and where they would have lived, and even what they ate. Like animals today, animals in the past ate meat or plants or both. One way to tell what kind of food animals ate is to look at their teeth. Sharp teeth are good for tearing meat. Flat teeth are good for grinding plants. When scientists find a fossil, they compare it to animals and plants from today. For example, when looking at the fossil of a trilobite, we can tell that it had a hard outer body just like a crab or a lobster today. And the fossil of a fern looks just like the ferns of today. This tells us that they haven't changed much in all these years.
Very good. Thank you.